We are going to now derive electric field due to a dipole at any point. At the start of this chapter, we have found out electric field due to a dipole at a point on its axial line, at a point on its perpendicular bisector. That means you can find out electric field based on those derivations. Either suppose if this were a dipole of charges plus q and minus q separated by distance 2d, and we know that electric dipole moment P will be equal to q into 2d. This also we knew that. So we knew that electric field at any point on this axial line or electric field at any point on this perpendicular bisector. So our derivation was answering electric field either in this line or in this line, not at any point. But our derivation of electric potential was more general, because electric potential we say 1 by 4 pi epsilon naught into P cos theta by r square. That was the definition. So at any point, so if there is a point up here, you just need to connect that point with by means of a straight line that gives an angle. So when you change the angle, it will answer for electric potential at any point. So our derivation of electric potential was more of general, but electric field due to a dipole was very specific, either on the axial line or on the equatorial point. So what we are going to do now is, based on that, we are going to find out electric field due to a dipole at any point, making use of the fact that electric field is the negative of the potential gradient. Negative of the potential gradient. Gradient meaning change in value with respect to distance. Suppose we have an electric field at this point, the radius vector is actually the position vector has to be position vector of this point P is by drawing a line here. See, this line is the position vector, it's a line, and you see this point electric dipole moment is from negative charge to positive charge. The direction of the dipole moment is this. The direction of the position vector is this, and the angle between this is theta. Now at this point, you know the electric potential is 1 by 4 pi epsilon naught into P cos theta by r square. We know that. But also we know that electric field is negative of the potential gradient. Potential gradient means change in potential with respect to distance. Now you look here, there are two possible change in distances. One is from this point P, if you move here along this direction by dr, this angle does not change, only the distance changes. Suppose keeping this as the radius, if you move along the circular track like this, only the angle theta changes, but what does not change? This distance, this length of this does not change, whereas this position changes. So along this also the distance changes, but this r does not change. Along this, the radial distance change. Here the angular displacement is taking place. Now we can write electric field in terms of two things. One is the electric field due to radial change in distance, and electric field due to when the angle changes. If the electric field radial distance changes, the direction of the electric field will be in this direction. Let me call the radial distance change as dr. And if you move along this direction, the tangential direction, let me call this change in distance. Suppose if you move through a small distance dr, if this distance is r, then if you move through a small distance dr, r plus dr, like that you will move on. Here, if this is theta, if you move through a small distance, small angular displacement d theta, there is a change in distance over here. Let me call that distance as dl. Now based on these two, you can write electric field as potential gradient in two different ways. One is electric field due to radial change in distance. Suppose if this increases, this will be equal to minus d by dr of what? Because electric field is equal to dv by dr with a negative sign, potential gradient. What is v here? 1 by 4 pi epsilon naught P cos theta by r square. So whenever you do this differentiation, this is actually a partial differentiation. Whenever you differentiate with respect to r, everything else has to be considered as a constant. So what is ER now? ER is equal to minus P cos theta, because when you move along this direction, theta only does not change, only the r changes. So cos theta is constant, P is constant, everything is constant. So P cos theta by 4 pi epsilon naught into d by dr of d by dr of 1 by r square. 1 by r square can be written as r power minus 2. So this will be equal to minus P cos theta by 4 pi epsilon naught into, this is minus 2 r power minus 2 minus 1, this is minus 1 by r cube, minus 2 by r cube. So what we are getting here is the electric field component along the radial direction is 1 by, this minus and minus will be cancelled, so 1 by 4 pi epsilon naught into 2p cos theta by r cube. This is 1. What about the other thing? So when you move along the angle, that means you are changing this, you are moving this way, this d theta changes. I said this small distance change as dl, so this r does not change. When you move along this way, only dl like that you are moving. Angle changes by d theta, d theta, d theta, d theta and so on, but this r does not change. So we know that for this, theta is equal to arc length by radius. So d theta equal to dl by r. Then dl will be equal to r d theta. Keep that thing in mind. So the angle when theta changes, electric field when theta changes will be minus of d by dr of v is 1 by 4 pi epsilon naught p cos theta by r square. But here r is change in distance along this way, which we call dl. That is why this dr becomes dl. But what is dl based on this definition? dl is r d theta. So we are going to write this as r d theta. The next step is going to be e theta will be minus d by, dl is r d theta, so it is 1 by r into d by d theta of 1 by 4 pi epsilon naught into p cos theta by r square. Since you are going to differentiate with respect to theta, rest of them are constants, you can take out 1 by 4 pi epsilon naught with a negative sign, which is d by d theta of cos theta, right? So p has been taken out, r and the square becomes r cube into d by d theta of cos theta becomes minus sin theta. Again, now e theta is going to be 1 by 4 pi epsilon naught p sin theta by r cube. Now that there are two components of electric field at this point, one electric field is along the radial direction, the other electric field along the tangential direction to this position vector. Now when two vectors are acting right angle to each other, then the resultant field will be the Pythagoras. You need to apply Pythagoras theorem to find out the field. So I'm just going to just rub this off, just see this. If there is any doubt, you just put a comment in the section, so I'll be able to just clarify your doubts by shooting a small video of it. Now that we have just found electric field along the radial direction is ER, which is 1 by 4 pi epsilon naught 2p cos theta by r cube we have found out, and electric field along this direction, angular direction as you move, it is 1 by 4 pi epsilon naught p cos theta by p sin theta by r cube. Since they are right angle to each other, then the resultant electric field E resultant, let us call it E, which is one is radial direction, that is you can write that angle as r cap, and this vector will be tangential to that. So the magnitude of the resultant electric field will be root over E radial square plus E angular square. So that is actually equal to root of, this E radial is 1 by 4 pi epsilon naught 2p cos theta by r cube whole square plus 1 by 4 pi epsilon naught p sin theta by r cube whole square. When you take up constant, you can write 1 by 4 pi epsilon naught whole square. When that has come out of the root, it becomes 1 by 4 pi epsilon naught. P also can be taken out, r cube also can be taken out. What you will be having is root over 4 cos square theta plus sine square theta. So what you can do is 4 cos square theta can be written as 3 cos square theta plus cos square theta. Cos square theta plus sine square theta becomes 1. So this becomes electric field. From this you can know electric field. The net electric field will be equal to 1 by 4 pi epsilon naught P by R cube, where P stands for electric dipole moment, into root over 1 plus 3 cos square theta. So from this is more general. From this you can also find out electric field due to a dipole at a point on its axis. If this point is on its axis, this point will be here, this theta becomes 0. When you put theta as 0, cos 0 is 1, then 3 into 1 is 3, 3 plus 1 is 4, root over 4 is 2, and we are getting electric field due to a dipole at a point on its axis, right? 1 by 4 pi epsilon naught, 2 by R cube. Along at a point on its perpendicular bisector. If it is a perpendicular bisector, this angle is going to be 90 degree. If cos 90 is 0, then root over 1 is 1. So electric field at a point on its perpendicular bisector is 1 by 4 pi epsilon naught P by R cube. So that way you can find out. The other thing is, this is ER, this is E theta, this is the resultant electric field which you have found out. This is electric field. Now the angle between the radial electric field and the resultant electric field, let us call it alpha. If this is E theta, this is E theta, the value is E theta, this is ER. Then if it is alpha, tan alpha can be written as tan alpha is equal to opposite side. If this is E theta, this value is also E theta. So which is E theta by ER. E theta will be equal to what we have found out, 1 by 4 pi epsilon naught P sin theta by R cube. So 1 by 4 pi epsilon naught P sin theta by R cube. This one is 1 by 4 pi epsilon naught 2p cos theta by R cube. Everything will be cancelled except sin theta by 2 cos theta, which is half tan theta. So alpha is tan inverse of half tan theta. If theta is the angle of that radial vector or the position vector with respect to the electric dipole moment, then the direction of the resultant vector with respect to the radial vector, alpha is tan inverse of half tan theta. See, there will be one more video on finding the electric dipole moment due to dipole at any point, electric field due to an electric dipole at any point. That is going to be even much more simpler and much more kind of conceptual understanding. So watch that video also.